Hi everyone, it's Caitlin here from Crystal Cove Conservancy, and I just wanted to give you all a quick crash course in how you can use Google Sheets to analyze and look for trends in our water chemistry data. When you open up the data set, the first thing you're going to want to do is make your own copy of it so you can analyze and edit the data set. So if you go to File, Make a Copy, you can save it to your own Google Drive, and now you can make changes and manipulate the data set. So once you open it up, you'll see that we have data for a lot of different dates. Each of these dates here was a day that we went out on the Marine Protected Area cruise and collected water chemistry data. On each of those trips, we collected data on the temperature, salinity, and pH. Each of these numbers here is the average temperature from the surface measurements all the way down to the 14-meter deep measurements. Same for salinity, it's the average of all the measurements at different depths and the average pH. So this is overall what the temperature of the water was on January 14th, 2015, and so on for each of these. So what your task is to figure out how we can take this huge data set with data from 2015 all the way up to the present, and how we can use it to look for changes over time and also for any trends. So we want to know if our water chemistry has changed from 2015 to the present, if there's an overall trend, and also if there are any seasonal trends. Are there certain times of year where our temperature, salinity, or pH are higher or lower? And are those trends consistent from year to year? And there are a number of ways that you can do that. So as you can see, there's a lot of data. So if you were to just graph all of this, it would be a bit of a mess and you would be a lot of variation, hard to see overall trends. But what you might think about doing is coming up with some averages to help analyze your data. So you might come up with averages for each month. You might come up with seasonal averages, fall, winter, spring, summer, or even an average for each year. So just to show you an example of what this might look like, for the salinity data in just 2014, I averaged together each month. So this could maybe help you see how things change seasonally throughout the year, and also how things change over time from 1 month to 12 months later in our data. You could, of course, do this for all of your data, not just 1 year. So to help visualize this, you'll want to insert a graph so you can see more visually what the trends look like, because with just numbers here, it's still a little bit hard to tell. So select all of the data that you want to graph, go to Insert, Chart, and then Google Sheets will automatically decide what sort of graph you should use, but you can also change it yourself. So right here we have a line chart, so you can see overall where our salinity measurements were each month. You could do this in a bar graph. Might be especially helpful if you're comparing categories, like a particular month over a bunch of years, or seasonal data. The other thing is if you're especially looking for a long-term trend over time with lots of variation, a scatter plot can be nice. And if you're looking for a long-term trend, you can actually add a trend line to your data. So if you go to Customize, Series, scroll down and select trend line. This can tell us overall if the salinity was increasing or decreasing over time. So for here, our series of time is just January through November of 2015, but this trend line tells us in general how salinity changed over this year. So you can first look at it just visually to get a general idea. Like it seems like this line is sloping upwards. That tells me that maybe our salinity was slightly increasing over the course of this year. But you can add some more data to our line to help better understand what's happening. Under Label, if you say Use Equation, that will show us the equation of the line, which also helps us understand what the trend is. So the slope of the line is this number right here. So for example, this is a really small number, tiny fraction of a number. So that tells us it's not changing a lot. The slope of the line is very small, so it's staying more flat than having a big trend over the course of this particular year. That number can also tell you if it's increasing or decreasing. If it's a positive number, it's increasing. If it's a negative number, it is decreasing. So this is a positive number here, which makes sense because our line is going up. The other piece of data that we can use to better understand our trend is the R-squared value. So you can add that to your graph here. What the R-squared value just tells you is how well the data points fit with the trend line. So how well the trend line explains your data. So an R-squared value of 1 would tell us that the data points fall exactly upon the line and it perfectly explains the trend. This one is 0.8, that's actually quite high, so our data fits really nice and tightly to this trend line. A smaller R-squared value would tell you that there is more variation and the line less closely explains your data. So let's take a look at an imaginary data set to kind of help visualize this. As you can see, this one is 0.8. Those lines fit nice and tight along the line. Here, our data, our imaginary data, is a little more spread out. And our R-squared value is 0.3, so it's a little bit lower. So there's more variation here. This trend line does a slightly not as good of a job of explaining all of the variation. That doesn't mean your data is bad, especially in ecology. There can be lots of variation up and down, but it's a good thing to keep in mind, especially if the slope of your line is very small. If the R-squared value is also really small, it's less likely of a chance that there is a real trend in your data. So it's something to keep in mind, but lots of variation is pretty normal in ecology because there's lots of factors that might play into what your data looks like on a particular day. So it's up to you to play with your data to both figure out if there's trends over time and also see what the seasonal trends look like throughout the year. Good luck. We're really looking forward to see what you find.